Alright, when is June 9th? Alright, let's do this. Max difference between even and odd frequencies. A given string, lowercase English letters. The task is find a maximum difference between the frequencies of characters A1 and A2 in the string. Maximum difference between the frequencies. A1 has an odd frequency in the string. A2 has an even frequency. Maximum difference between even and odd frequencies. So 1, 2, 3, 4, 5. 5 minus 2, right? So that's odd frequency, B has even frequency. So basically we'll check for the even frequency and check for the odd frequency, and then we keep A1 is odd, so we keep the maximum on the odd and the minimum on the even, right? That shall do. Okay. Alright, so we're gonna say even, odd, oh, that's actually not. No, we have to also have a vector counter. Right. So it's a counter C minus A plus plus. If counter C minus A mod 2 equal to 1 is odd, then even shall equal to maximum even. Wait, hold on, that's not even, that's odd. And counter C minus. Alright, I'll do this multiple times. Index. Okay, so index. Okay. Else even. Right? Odd minus even. Shall do. Oh! Sorry. Typo. I don't know why. Like, just things that just happen. Oh, even is min. Dude. This one shall do. Oh, maximum difference. It could be negative. Huh. Wait, hold a second. Maximum difference. Four, and then 1. How did you get to 1 anyway? odd is 1. Even is I don't even think you should. Odd becomes 3, right? Yeah, odd becomes 3. And even is no, even minimum even is 2. Minimum even is 2. Odd is 3. Okay, this is not right. This is not right. So the difference can be negative, which means wow, but this question is the maximum difference. And we have to go through the whole thing first, right? Go through the whole thing first, and then we'll loop through, and we need to find basically the maxed mean, maxed even, maxed odd, and the min even, min odd. So that's actually completely different. We have to redo this thing completely. So we actually don't need this. We can just say this. Don't need any of this. Right? Okay, and then we're gonna say min even, max even, min odd, max odd. Actually, we have to redo this. Min should be s dot size plus 1. Max is going to be 0. Min is going to be size minus 1. Minus 1 plus 1. Max shall be 0. Alright. And then for int c of counter, right? If c is larger than 0, and if c is larger than 0, and then you have to check if c is even and c is odd, then min odd shall be minimum c, and then max odd, max odd and c. Alright, else min even and max even, alright, and then what do you return? Alright, we shall return so it's gonna be max odd minus min even. If it's larger than, what if it's the same? What if the difference is the same? Like 1, 2. Okay. I don't know if they're the same. Is it possible for them to be the same? 3, yeah, 1, 2, 3, like here. So 1, 2, 3, right? So we say 1, 2, 3. What's going to be like this? So the max even is 3, mean even is 1, and odd is 2. Good question. I guess you return the positive value? You do return a positive value. However, if I don't have the CCC, then you'll return a negative value. Yep. Alright, so essentially we say if it's larger or equal to min odd minus, actually we should say max even minus min odd. Right? When that's true, we'll return max odd minus min even. Otherwise, we return min even minus max. Min odd minus max even. It looks very convoluted. Negative 3. What the hell? One, two, three, 4. Wait a second. Wait a second. Expecting negative 1. 1, 2, 3, 4. And I have 1. What? M 1, 2, 3. M is 4. Right? S is 2. Y is 1. Huh? So this you're telling me should be these two because it's bigger. Wait a second, that's not how we do the other one. 1, 2, 3, 4. Z is 1. S is 1. Oh, that just so happens that it has to be like this. Oh, we're not supposed to do it that way. We're supposed to just get a maximum. We don't have to do the other way. I don't know. So it should be max even, no wait, min even and a max odd. It is min even and max odd, but that's about it. Min even and a max odd. And then we just do min even, no, max odd minus min even. Alright, I think that shall be it. Wow, so much time spent on this problem. I think it's just I didn't understand the problem very well. There we go. That's the one. I don't know. I spent a lot of time on this. Alright, anyway, so we're done with this. Do we want to get another one? We can do another version of this. Right? I remember this problem. It is basically have a string and you want to hold empty string, apply one, remove the first character from this string, give it to the robot. The robot would append it to a T, remove the last character T and give it to the robot. The robot will write this character on paper, return the next to smallest. So basically we go S from left to right and then we push into the stack, which is T, and then we want the smallest to come out first, right? So the ideal is we will have a mechanism to find the smallest in the remaining s. If there is a smaller one, we shall wait. Just keep going until we hit that one. And when we hit that one, we'll add that one in. So my original solution was to get a queue, right? And a priority queue. So we always keep the smallest popping out on the right hand side, and we use that to compare to the left, to whatever is on the current thing. And if we have a smaller on the right, then we just definitely use it. Right? If we don't have a smaller, we just keep adding. And if the top of the stack is smaller than the smallest on the right, we use that. That's kind of the mechanism. Now we can use the exactly same idea here, the editorial, but without relying on a priority queue. So basically what we do is we iterate through everything and we get a counter of all the letters, right? We have a pointer to point to that, so we know the count of the smallest, okay? So we basically have to move forward until we hit the count that has the smallest. And then, that's the smallest, then we start adding, right? We start adding to the stack. And every time we add it to it, we shall remove from the counter, right? Because we're consuming it, right? We're consuming it. So to suppose the counter not pointing at the smallest, right? And then we are adding something to the stack. And as we add to it, the counter lose values, right? The counter lose things but those we don't want to print out because those are bigger. So we want to wait until the smallest to come out. So we keep going, right? We keep going until I would say until we exhaust all the smallest, and then we can print out. But I'm not sure if that's right. We should print out as early as possible. When we get a small, we should just print out, right? So basically, if we hit, so we get one, and we'll minus, right? And we'll compare the top and what we have. If the two are the same, then we should just use it, right? We should just use it, and then we'll move on. Right? If it's the same, we just use it. And then we move on. And then we shall, every time when it becomes 0, we shall move forward. So I think I have some idea of how this one should be done. 2, 3, 4, 3, right? 2, 3. So I can do this. Actually, it will be easier. I can just say LeetCode 2, 3, 2, 4, 3, 4. 2, 4, 3, 4. So basically this is very similar but with a better implementation. The idea originates from the editorial. Essentially we keep track of the smallest letter in the remaining s, right? And compare the top of t to that smallest letter. If the top of t is smaller or equal to the smallest letter, right? The smallest letter in the remaining s, we use it, right? Otherwise, we keep pushing new letter to the stack. The ingenious part is that instead of using a priority queue to keep track of the smallest letter, we use a counter. right? We use a counter because we always know, right? Because we always know what letter is the smallest, right? What letter is the smallest? We start from A and right? Once a letter's count decreases to 0, we move on to the next letter with a positive count. That's kind of how we are going to do it. And this will result in O n. Alright, so to start with, we need a vector of int, called a counter, right? And then we need to go through everything s, and then call it counter this plus plus, right? And we need to say ci is 0, and we need a stack. Unfortunately, we need a stack. Do we need a stack? We do need a stack. Because we need to keep track on what, right? We'll just call it stack. Stack of char. We'll call it stack st, right? And then what's next? We basically go through char c of s, right? Char c of s. We always add it to the stack. Well, I should have a result. Okay, so we add it to the stack and decrement from this. Okay, we say while counter ci is equal to 0, then ci plus plus. Okay, well, so ci is smaller than 26, and this. So ci now pointing the smallest, right? And we say if st.top minus a is smaller or equal to ci, and then we will pop it, right? And then we will say res.pushback st.top and st.pop. And then we keep going until we consume everything. And then at that point, we can return res. Okay, let's check. Let's see if it's right. We have a bunch of test cases for this. That is very wrong. I think that just means at the end we have stuff in the stack, right? I think that just means at the end we have stuff in the stack, which is fine. We can just say while stack.empty, right? Well, stack is not empty. Res. I mean, we can just basically reverse it, right? Res.pushback st.top and st.pop, and then realize this one is so important. But now you know. Almost. BAC is wrong. Interesting. So we have BAC, right? BAC. So we got B, and then pointer is 111, right? CI is here, which is A, B, and C. So So B, this one becomes 0. Next, A pointing in, this one becomes 0. And then CI move into this. And then, if this, the top of this is smaller than CI, which is true, so now result becomes A. So this one is gone. Oh, so it's just a while. st.empty and there we go. $51. I think it's a better performance than the last time we did it. Right, so last time I think it's like 9%. Oh yeah, so much better, right? Okay, so this one is done. Let's just double check. We have counter, we have a stack, we have a result, a minimum character, go through everything, we'll push it back, minus minus, while this, well plus plus, while this, we'll do that, and then, ooh, I don't have to do the last one. That's true, we already did this, so we don't have to do this. Nah, might as well, it's fine. Don't think because this will always be empty, so this will skip. Alright, that's that. I think we're done with this one. Okay.